Okay. We're talking about the parents instructor and abstract classes. Okay, got it. Okay, and also I guess as we have the trickling effect where make sure you're checking Slack every single day, or set up the notifications or whatever to come to your phone. And just so in case you're not aware, if you are in the 325 class following this, I don't know if Blade put up a lab or anything, but you won't be meeting as a class because I'm picking him up coming out of his surgery on his leg here right after class. All right, so last time we started talking about inheritance, and we were talking about what is the thing that distinguishes a player from a monster. And so at least as a starting point, well, I think what was discussed kind of at the end of class was that a player has interactions with the person at the keyboard, where a monster kind of does their thing on their own. So at this point, that is the distinguishing factor between players and monsters. We may further distinguish those as we get further into our game here. But at least at this point, that is the distinguishing factor. So what we did is we're going to create a core class, and I think we already started doing this. Let me pop over here. Let me just make sure everybody's accepted into the room. Yeah, they are. I'm lost. All right, here. All right, so we already created this inhabitant class here. It's not very interesting at this point, but we have a public class inhabitant, so nothing special about this class at this point. And what we do for player is we say that player extends inhabitant. So a player gets everything that an inhabitant has automatically. It gets all those things. All right. But then it can further distinguish itself from a inhabitant. All right. Similarly, we will have a class called monster, and I'll go ahead and just create that class now. Monster.java public monster, and this guy extends inhabitant. Right. So same type thing. Right off the bat, a monster is an inhabitant. All right. So what we want to do is we want to talk about, well, if inhabitants, so first of all, we look at player right now. I'm going to steal that there. I'll actually just steal this whole constructor. We'll rename it. All right, so when we first build anything that is an inhabitant, we're going to be talking about, I think I asked the question at the end of class last time as we were kind of starting this discussion, whether or not we would ever create this generic inhabitant, or are we only using it as a building block? All right, we'll talk a little bit more about that in a second. So regardless, inhabitant does have a constructor. The question will be who uses that constructor is what we'll talk about. Okay, but to create an inhabitant, any of our inhabitants, we're going to need a name, and we'll set this inhabitant's name to that name. And then we automatically default the current room to null. All right, so any kind of inhabitant, whether we're building a player or whether we're building a monster, we are going to create that inhabitant initially the same way right now. Okay. So that means that for inhabitant, since they're doing this work, it would be redundant for a player to do that same thing. We don't want to have that code repeated. All right, so go back in here. How does an instance of a class refer to its parent? So remember that the this keyword is how an object refers to itself from within itself. But how does an object refer to its parent from within itself? Anybody remember that guy? We got
Papa?
nothing. Go ahead.
Papa?
So it'll just be Papa Dot. Papa Dot. You know what? There may be a programming language out there that does actually do that. Geeky people do tend to have some weird sense of humors. When I was, I think I was maybe 11 or 12. I was taking a programming class at like the local junior college. I'd already been coding for a little bit. And so this is kind of the I'm going to wrap this into kind of a lesson. So it's not just the story time. You know, I've mentioned that you should always name your variables something reasonable based on what the variable does. Well, so I would call this guy a very bad programming teacher. But in any case, he just purposely named all of his variables after like Gothic, historically Gothic words. So you didn't have any clue what they were. But somebody like that, what they were going to be used for. But somebody like that, I could see if they wrote a programming language having, well, maybe not Papa, but maybe like the Latin word for parent or father or something like that. All right. Anybody else know what the actual keyword is to refer to the parent?
Is it super?
Yeah, super. So super is, let's put it this way, we'll say the super keyword is how an object refers to its parent from within itself. All right, now we do need to think about this. So we're going to say this happens in two distinct ways. So the general use is if I want to call upon one of my parents' methods, for example, I would say super dot something like that. All right, and we'll see an example of that today. Well, if not today, soon. We'll see how we stumble through things today as we make our progress here with inheritance. But in any case, so the common way, we'll say commonly, a method can call upon one of the methods of the parent class by saying, well, I'm going to say call upon one of the instance methods of the parent class. It's non-static. By saying super dot method name params, whatever. All right, so similarly to how we would say if we want to call one of our own methods inside of our class, I think we do that in plenty of different places. For instance, here in play, we say this dot look around. So we're saying I want this object to call one of his other methods. In this case, it's called look around. All right. So the antithesis to that would be, you know, let's say your parent had something like super dot do something. whatever. This would ask your parent to call their own do something method. All right, now, I guess let's go ahead and go down this path. Well, I don't want to go down that path too far right now, because I'll explain it when we do this other thing. All right, so that is one way of accomplishing or using the this keyword. Now, we might also use the super keyword to refer to our parents' constructor. This must be the very first thing that happens inside of the object's constructor. All right, we're going to see this by an example right now. So, since we've decided that I've written a player constructor, because sometimes I'm going to build a player. We've already done that here inside of main. I build a player right here. So player, the player equals new player, and I'm passing it the name, Mike. Now we've decided that actually the stuff that's currently happening inside of this constructor for player can actually happen at the inhabitant level. Right? This player is already getting all those variables, the name and the current room. Remember, we did this last time where we introduced the protected keyword, which exposes these variables to not just the inhabitant class, but also children of the inhabitant class, as opposed to using private, which makes it only available inside of inhabitant. So having these guys set as protected like we do right now means that this is legal code. Player does have access to those variables. But what we don't want to have is we don't want to have a situation like this, where inside of our monster class, we do the exact same crap. Now you have this code repeated in both monster and player when both of them actually are inhabitants. Okay. So what we would actually do is we would say super and pass it the name. Same thing in player. We would say super, pass it the name. This calls upon our parents' constructor, passing it any parameters the parents' constructor is expecting. So in this case, the parent is inhabitant because we are extending inhabitant. The parent's constructor expects a single string. So we will pass it a single string, and it just happens to be the string that was passed to the player constructor. Okay, so that's one thing we might do, but this has to be first. Must be the first line in the constructor if we choose to use super. So if we choose to utilize our parents' constructor, which we will sometimes do, sometimes we won't. Sometimes your constructor won't do much, or your parent is for name purposes only. It doesn't actually accomplish anything. But we've decided in our model that both players and monsters are initially built in the identical way. They initially come into existence with a name and a null for current room. All inhabitants, whether they're players or monsters. So we're going to write that constructor, that logic, a single time. And we would actually, well, I'll talk about that. Well, I'll talk about it now. We would actually make the constructor here protected because we do not want it publicly available. We do want it to be accessible by our children. the children of the inhabitant class, so that they can do something like this. They can call upon that constructor. So notice they're not saying inhabitant here. They refer to their parent using the keyword super. All right, but this syntax right here, where you just say super followed by parentheses with whatever parameters are required in there, this is the specific special case of using the super keyword to call your parent's constructor. This is distinctly different than something like super dot do something. Yeah, Tamish.
So that is specifically calling the constructor. It's just super, and then you a parameter is that is specifically calling the constructor.
Yeah, this 100% calls this dude.
Okay.
Yep.
You don't have to do inhabitant, super inhabitant. It's just super.
Nope. Nope.
Okay. Sweet. Thank you.
But it's a good question, because there's some historical things involved here. So just to reiterate, if you're calling your parent's constructor, you always do it this way. You cannot say inhabitant. All right, so this is how you call your parent's constructor. And the rationale behind that, or the reason that it works this way, in case you've done something maybe with C++, is Java only allows a class to extend from a single other class. Now, I'd make the argument that that makes a whole lot of sense. When we think back to the beginning of this course, we talked a lot about how Java made some decisions that kind of made the life easier for the programmer, something like that. So whenever something always happened in a certain way, Java said, well, we're not going to make you write extra crap. We'll just make it work that way. C++, as well as some other older object-oriented languages, allowed something called double, I think it was called double inheritance. I think it would actually be multi-inheritance, because I don't think it was limited to just two classes. But in any case, in C++, you can inherit from more than one parent. So you can get some stuff from 2, 3, 4 different classes. With that in mind, this super syntax might be a little bit more suspicious, because now it's like, well, which of your parents are you actually referring to here? What we typically see in modern object-oriented languages is we see this hierarchy approach that we've looked at here. If you want your class to inherit from 2 other classes, what you would do is you would have a top level class, then you'd have another class that inherited from that. And then, for example, maybe we have player inherit from that. All right. So you can still have player get stuff from more than one class, but it would have to get it from like its grandparent. It would be a lineage like that. Now, we do not directly have a way of talking to our grandparent, though. We can't say super dot super. We would have to pass the buck up. So we can call a function of our parent. For instance, if I wrote do something inside of inhabitant, let's just go ahead and do that right now. We'll say protected. Do something system dot println inhabitant, do something like that. So we have a function inside of our inhabitant class called do something. Our player is then, while the player is being built, after they call upon their parent's constructor to go ahead and initially build the player, they can then also go and call stuff from their parent. All right, so let's see this work quickly. What I'm going to do here is I'm not going to have the player play, just so we can just see this first part. So now when I create my instance of player here, it's going to come into the player constructor. passing the name of that player, I passed in Mike. It's immediately going to say, okay, I'm going to let my parents constructor initially build me. So the parents constructor is going to go ahead and set the name equal to the name variable and current room equal to null. But then the player constructor takes one more step and says, you know what? I'm also going to go ahead and call my parents do something method. So go back here. Oh, I didn't put a return type for this guy. Oh, capital. I said I was going to rename the I did an uppercase S for do something in the parent. Do something with a capital S. All right, so now we see that while that player was being created, they also called upon their inhabitants do something method. As opposed to, when we go into player here, I'm going to just create a method. I'll go ahead and say player do something. So super do something calls upon the parents do something method. This dot do something will call this guy's do something method. So we'll see them both happen now, but they're happening, you know, we're asking our parent to do their thing, and then we're asking ourselves to do our thing. Oh, it's saying we can't override it because we've made this a stronger. I have a method called do something here. My parent has a method called do something here. This guy is of type protected, attempting to assign weaker access privileges, used to be protected. So when I do override it in player, for this example, this is not something I probably would do, but I'm creating my own version of do something here inside of player. I need to make it protected because this guy is overriding the one I got from my parent. And we can actually see this in action here. Right now, I'm explicitly calling my parents do something. Right here, I'm explicitly calling my do something. Now, if I don't use those super or the this keyword, and I just say do something like this, because I'm in an instance context, this guy will call the most local definition of the do something method, which is the local one that's owned by this player. So this guy right here will be the same thing as calling this dot do something, because we have overridden the do something method that we got from our parent right here. So we have a more local version of that. All right, so now when we're building a player, we should get the output of our parents do something, then the output of our own do something, the players do something, and then we'll see the players do something again. All right, so there's my parents, there's the players, there's the player again. So this hopefully kind of drives home the point where I'm an advocate of always using either super dot or this dot. Be explicit. If you want to call one of your instances methods, say this dot, even though we just proved that as long as we are in a non-static context, we don't actually have to put this in front of it. I would still encourage you to always put this in front of it though. Now, nothing keeps us. So even though we have a more local version of do something, nothing keeps us from having our more local version still call upon our parent. So just because I've said that this method here overrides, so a little comment here, overrides the method, I will call it the do something method of the parent. Just because it overrides that does not mean that that method of the parent is gone. Okay, it's just been locally replaced, but I can still get to it using the super keyword. All right, so now when my constructor gets called, I'll ask my parent's constructor to do the initialization. Then I'll call my own do something method, which prints something out, and then calls my parent's do something method. So there's the players do something. Then there's the parents do something. All right, make some sense? Now, what I'm going to do here, just for the sake of, I'm going to make this guy public again. So we're going to have a public constructor for inhabitant, and we'll see if this still works. Nothing's really changed. Except I now have the ability to do something else. I'm going to say inhabitant I1 is equal to new inhabitant Dave. All right. And this is allowed. I'll go ahead and do a system.out.println in inhabitant constructor. Like that. So whenever the inhabitant constructor gets called, we're going to just print something out to prove that we're in there. It should get called 2 different times. It gets called by our players constructor. It will also get called when we directly created an inhabitant here. So we'll see it occur 2 separate times. So there's the in inhabitant constructor. There's the other in inhabitant constructor. All right, so now we ask the question, and actually let me go ahead and switch this back to protected. And I actually think this will still work, even though I teach it as if it shouldn't. Yeah, it does still work. So the way I teach protected, at least at this level, is that protected means something is only accessible to its children. Although we are inside of main here, calling upon our inhabitants constructor, which is actually protected. So kind of not as I've advertised it, but let's just say that that's how it works. You would only use protected at this point whenever you're dealing with inheritance. All right. So I'm going to change this back to public for the rest of this little example. All right. So I'm now creating a player, but I'm also creating an inhabitant. And we asked the question last time, does it ever make sense to create a generic inhabitant? Or in our game, are all inhabitants going to be either players or monsters? Realistically speaking, we'd say that having a generic inhabitant walking around probably does not make sense. Inhabitants only exist as the building block on top of which we build players and monsters. Okay. But we see here, nothing is preventing me from creating an instance of inhabitant. It's allowed. All right. Now, we could decide, okay, well, as a programmer, I'm just going to choose not to create instances of inhabitants, even though we technically can. We're proving it right now that we can create instances of inhabitant. Now, maybe if you're the only one using your code, this isn't the end of the world. I would still encourage you to do what we're going to be looking at here next. But also consider that sometimes you might be providing code to somebody else. You might be writing a library that you put up there on a GitHub repository or something like that for the general public to use. And they might not know that your intention was for them to only do certain things, and certain things just didn't make sense. Typically, good programming practice would be to say, I'm going to make sure I lock down my code so that the only way of using it is the correct way of using it. Don't let them do things that in ways that it wasn't intended. And that's where we have the abstract keyword. So abstract means that you can not create an instance of a class. So actually, I'm going to specify this a little bit more. Abstract class means that you cannot create an instance of that class. It's not allowed. You'll get an error. Let me show you that. We'll come into our inhabitant here, and I'll actually make this guy abstract. Now, abstract is not an alternative to public. So you can still have this guy be public or abstract public or public abstract. I don't think it matters the order in which you put those. All right. So abstract is another qualifier other than protection, like public, private, protected. But abstract, having this class be abstract, says you can't make a direct instance of inhabitant, which means that this line right here should now be an error. Inhabitant is abstract. It cannot be instantiated. So what we've done now is we've locked down our code to the point that it's self-policing. We're not going to let somebody ever create directly an instance of inhabitant. They can indirectly create instances of inhabitants, because every single time we create a player, an inhabitant gets created. Whether we call our parents constructor directly or not, if we don't actually utilize our parents constructor, this will call the no argument constructor of our parent. So we see here that it is automatically calling my parents constructor, but what it's doing here is it's doing this. It's trying to call that constructor. Okay, so we have that same error. Well, it's written very similar. It is the same error. All right, so even though we didn't write super here with no parameters, we see that it is getting called that way. It's happening magically for us. All right, so whenever we have a class that extends another class, that class will automatically call the parent class's constructor, even if it's saying, okay, well, if the parent class doesn't actually have a constructor, for example, if I remove this constructor, go back to, oh, it's still in monster. That error. Okay, so now the error about calling the constructor went away. This means that we can't create an inhabitant. That's because it's abstract. But this guy right here is calling my parent's constructor, just like we do right there, where I actually put it in there. Okay, so this line right here is assumed to be there if I don't directly call my parent's constructor. And if my parent has a constructor that I've written explicitly, like this, it does not get a no argument constructor. So I'll go ahead and run this again and I'll explain that. Okay, it's telling me that the constructor inhabitant and class inhabitant cannot be applied to something that takes in a string or doesn't take in a string. That is, in inhabitant, we have explicitly created a constructor that takes in a string. Since we've chosen to actually write a constructor here, what doesn't automatically get created for us is that guy. A constructor that takes no parameters and does nothing. So if we don't explicitly write a constructor, an invisible one that looks like that will be created for us explicitly to support this, which automatically is happening inside here. Whenever we create an instance of something, a constructor, it will always have this line at the top of it invisible unless we write our own. And that is to support the inheritance model. A player is built on top of an inhabitant, which means that even if we don't have a specific constructor for our inhabitant, we still do need to create an instance of inhabitant so that that super keyword exists. Make sense? And similarly, inside of inhabitant here, just as it worked in player, super is getting called there. Who is inhabitant's parent? Who do you think inhabitant's parent is?
Is it the object class?
Yep. So this guy extends object. So if you don't explicitly have your class extend some other named class, it by default will extend object. All object-oriented languages have to have a top-level object on which all classes will be built. Okay, so this is our hierarchy that we have here. So we have a player, which is an inhabitant, where an inhabitant is an object. All right, so even in this constructor right here, where we actually did write our own inhabitant constructor, there is still the invisible line here at the top, super, that will call upon objects, no argument constructor that does whatever sort of magic has to occur inside the Java virtual machine to instantiate a generic object thingy. All right. Because an inhabitant is an object, a player is an inhabitant, which means a player is also an object at some, lineage level.
When you use super in that way without like the super dot, does it always refer to the first parent constructor? Like how does it know not to refer to the do something one?
So when you say super followed by parentheses like that without the dot, this is our special syntax to call upon the parent's constructor. So this is,
And since the parent constructor, like there's two constructors in it, how does it like distinguish between the two?
all right, so you mean like in this case?
Yeah, so
Okay,
like that has super, and then if
It
you
does-
did super dot do something, I know it would go to the do something constructor, but how does it know to go
do
to?
something's not a constructor. Do something's just a method. I have a
Oh,
method here,
okay, I got it.
and I have a method in here. Yeah, those guys are different kinds of animals. These guys are just methods, not constructors. Remember, constructors don't have a return type and they match the name of the class. And then just to reiterate, I think you understood it at the end there, but just to reiterate, because I chose to write this inhabitant constructor here, that invisible constructor that takes no parameters like that never got created. Java will only generate this for us automatically behind the scenes if we choose not to write our own constructor. And that is so that it supports the instantiation of object syntax. All right, but since we decided, okay, well, when an inhabitant is built, I'm gonna actually do something. So I'm gonna write something here that lets Java know, look, I got this. You don't have to help me out. So only that the constructor we wrote is in existence, which means that inside of player right now, this line is an error. Whether I type it there or I leave it out and let Java magically put it in there for me, it's currently an error because there does not exist a no argument constructor in my parent inside of inhabitant. The constructor inside of inhabitant takes a single argument, single parameter. So it's going to scream at me now about that. This is where it's screaming at me. It's expecting a string, but we gave it nothing. And then secondarily here, we see that outside in main, we can't build an inhabitant directly because we have specified that the inhabitant class is an abstract class. It exists solely for other classes to be built on top of it, not for it to ever be instantiated on its own. So hopefully the way outside of the abstract keyword, the inheritance stuff, you can think of very similarly to how real life works. You have one set of biological parents and so let's just say in our case with coding here, there aren't two parents, there's a single parent, and you get stuff from them and then they have a parent that you also get some hereditary stuff from. All right, so it works very similar to how real life works. You don't have to memorize something new. All right, so questions, comments, concerns, bribes. All right, so we'll come back on Monday and we will expand our code to allow there to be monsters as well. We're going to still stick with a single player for right now, but we're going to allow monsters to be in there. And then at some point next week, we're going to introduce multi-threading to have our world come to life, if you will. All right, I'll see everybody on Monday. Remember, you do not meet for 325 if you haven't been following stuff, because I'm picking up Blade from the hospital in a few minutes. All right,
Wish him well for us, sir.
I will. I'll take a picture as long as he's presentable and okay with it. All right, everyone have a good one.